Hey, good afternoon, everyone. My name is Dan Painter. I am the Product Training and Development Manager at Flint & Walling, and I will be hosting our web conference this afternoon entitled Why Wolf? Wolf Pumps is a company that was acquired by Flint & Walling, I believe, back at the tail end of 2012. And it was a category of product that Flint & Walling needed to be able to round out our entire product offering, which that was in the form of submersible inline shaft turbine pumps. So these conferences, as they typically go, won't last a whole hour. And a couple things right out of the chute. Before we do get started, I am currently working on a schedule for the month of June. I'm going to throw in more topics, just kind of a variety of topics. So I encourage you to check back to the website for that web training, web conferences that are going to be scheduled. We're going to keep this going as long as we're under this whole COVID thing, and we'll just keep it continuing as long as we get people to show up. So anyway, with that, I'll try to bring my cursor up here so I can use it, and we'll go ahead and get started. When we look at, and by the way, this whole Why Wolf presentation, you know, we all have choices when it comes to virtually everything in our life. And so, you know, for somebody to decide on what brand or type of submersible turbine they want to put down a well or whatever the application may be, this presentation, I guess, is things that we feel pretty strongly about as far as those things that we'd hope to be considered when choosing Wolf. But that said, the applications for Wolf pumps, they're primarily sold to a nationwide network of wholesale distributors. Some of those are build centers where they will build these submersible turbines right within their facilities. And Wolf is very instrumental in setting those kind of customers up along with training. But typical applications, as you can see at the bottom of your screen, real heavily into agricultural irrigation. Anytime we see pivot irrigation systems out there, we know that those are markets that these pumps fit in. And so they're all over the area. For instance, between Fort Wayne, Indiana, where I reside, and Chicago, Illinois, you've got to travel across northern Indiana on Route 3 or Route 30. And on both sides of the road for miles and miles, all you'll see is these pivot irrigation systems out there. So there's a pocket of real strong submersible turbine markets right up here in northern Indiana as they exist throughout the country. In addition to the residential and turf irrigation, livestock watering, mining and saltwater applications, small municipalities. So lots of applications for the Wolf style pumps. Basically, what I'm going to do from this point forward is tell a story. Wolf was founded back in 1951, so they've been around for a while. They're a family-owned, privately owned business, and like I said, they were acquired by Flint & Walling along about 2012. But Wolf was headquartered out in Abernathy, Texas, which is in the western portion of the state. You can kind of see the little star down there on the bottom right of your screen, just above Lubbock. But one of the things about the location where Wolf is located is it's that part of the country has got some of the most abrasive water conditions, not only in Texas, but in the nation, quite frankly. Prior to getting into the pump business, I spent about 20 years in water treatment. And I can tell you personally that I've been into the West Texas markets. Nobody drinks water out there. They all drink bottled water because they have such high TDS, but they do use the water to work with to irrigate and flush toilets and things like that. So, but it's very, very abrasive water conditions out there. I'm looking to make sure my slides are transitioning on your screen so I can keep my voice kind of tuned into the slides. But anyway, under normal applications, and I don't know how many companies would be bold enough to actually state this, but we anticipate and fully expect a 15 to 20-year life expectancy on a Wolf manufactured submersible turbine pump. You couple that with a warranty rate that is trending less than 0.25%. This may be my opinion, but in my opinion, Wolf will outlast any pump out there. And of course, some people want to know why that is, and that's kind of why we determined that this topic, this title for this web conference should be Why Wolf. This is the current Wolf facility in Abernathy, Texas. This is very new, within the last 3 or 4 or 5 years. This large tower that you see here, I will be referring back to that later in this web conference, but that's a world-class test facility that's enclosed within that tower. And again, I'll circle back on that as we progress through this web conference. If you were to ask Wolf what it is they do, they could answer that pretty simply. They would basically say that they make 5 sizes of submersible turbine pumps. Now, this is a little dated. They actually go to 10-inch today. And as I mentioned early on, they've just added a line shaft turbines to this mix as well. But it wasn't too many years ago. That was an answer, and it was in fact correct. They make 5 sizes of submersible turbines. Here's some things that I think are important to know about Wolf. And it's very much part of the whole Zoller company philosophy and integrity that's ingrained amongst our divisions, Flint and Walling being another division. And that is that we do a lot of quality checks. So all incoming goods and components are going to be quality inspected before they're ever put into inventory, and they're going to be tagged such. And we do that same thing in Kendallville. I know that Zoller does the same thing in Louisville, but we're going to look at these components as they come in, and we're going to inspect them. So that's one of the first quality checks that takes place. And this can include all the bowls, all the mounting brackets, all the discharges, all the impellers, shafts, bearings, and bushings, everything comes in, gets quality checked. At Wolf, they do a significant amount of machining. They have a machine shop down there that's fully loaded with these CNCs that you see. But a lot of these raw castings, when they come in, this is what they would look like. But as they go through these CNC operations, such as the impellers up here, those things will be machined to perfection, along with the bowls and the discharges. So like I mentioned, there's a lot of machining that takes place there at Wolf, and that machine is done precision. Things will thread together, things will go together, and I know that this industry is not entirely that way. A lot of secondary machining takes place with, other brands. So I want to point out that along the way, each one of these machining operations will also have quality inspections before they're actually going to be used in production. And so each step along the way, quality's checking dimensions, checking all the parameters to meet that protocol. And then, like I mentioned, all components are going to be re-inspected before use. When it comes to shafts, this is how Wolf treats shaft material. The shafts are going to be cut to length. They're going to be tapped. They're going to be bored. And then the next thing that we're going to do is we're going to make sure those shafts are straight. And so we're going to straighten those shafts. And actually at Wolf, once those shafts have been straightened, they are racked vertically, as you can see in the image on the right. Those of you that have an opportunity in the future to take a tour at Wolf, or have in the past, this is something that is very visible when you go into Wolf, as you'll see all that shaft is being hung vertically, and there's a reason for that. And some of the reasoning behind that is that a straight shaft is important, particularly in a submersible turbine pump, because you don't want to have any bends, sags, or angles, or curves, or anything like that. So sometimes when stainless steel stock like this is stored horizontal, much like well casing is stored, you can end up with sags, and we want to make sure that we avoid that we have a fully there's a word for it, but centricity, I think. Anyway, straight shaft, it eliminates any of the vibration that could overload bearings, and it adds longevity to the bushings that are used in a submersible turbine. So those straight shafts are very important. When it comes to options, and this is where Wolf really, really shines, at least in my opinion, is they have the options that they can put a pump together that would last in darn near any environment. And I can tell you for a fact that there have been applications where other competitors have used pumps that they could not get more than 3-4 months of life out of. And Wolf goes in and says, well, we can put the components together to accommodate your particular application. And they did. They put that pump in. That pump's still in today. We're talking past 3 years now. So, 3 months versus 3 years, it all had to do with some of these components. So, for example, when it comes to shaft material, you can get 416 stainless steel, which is an industry standard, has corrosion resistance, it's affordable. But in cases where we need greater corrosion resistance, like an application I mentioned just a minute or two ago, we have 316 stainless steel, and of course we also have 17.4, and we're going to use that 17.4 in any pump that's going to be over or 250 horsepower. So it's for high corrosivity and high torque. We also have a chrome shaft. That's a very, very hard material, and it's great for abrasives and particulates, fine sands and abrasives. And then there is an ion material. This is really cool. It's very low friction, no peeling. This is not a dipped shaft. This is done through some type of electricity or electrolysis. I know an ion is an atom that has either a positive or a negative charge, so it just changes the molecular structure of this thing. It's not a coating that goes over the top. And there's more shaft combinations than that if needed, but these are some of the most popular ones that we use pretty much day in and day out. When it comes to the bushings, again, several options there when it comes to bushings that are going to be put on that pump shaft. For example, there's a rubber bushing. It's pictured up there on the top, the black one. Indicates it's fluted to allow particulates to be directed through that bearing, and that fluting is it's kind of there are spiral grooves cut through the inside wall of that rubber bushing, and that's to allow area and pathways for the particulates to be directed through. There's the bronze bushing, which is an industry standard. Oftentimes, a bronze bushing can be used in conjunction with other bushings just because it will add stability and strength, particularly if you're building, several stages together. You get 2 or 3 stages, not a big deal, but you get, 12, 14 stages. You want some stability in there on those bushings, and that bronze provides that. The silicon carbide that you see on the far right-hand side, the black 2-piece bearing assembly, is a very hard material. We know a lot about silicon carbide up at Flint and Walling. It is the material that we use on our mechanical shaft seals on all of our above-ground pumps. It's a far superior material, and it does protect against abrasives and particulates. Also can handle heat. Then the Vesconite, speaking of heat, that can be used in applications where you have high temperatures and or you need additional chemical resistance. But the Vesconite bushing is pictured in the top right-hand side. And the one I think is probably the coolest of all is actually a proprietary bushing for Wolf. It's an exclusivity. And it's a 2-piece like the silicon carbide you see pictured there. It's a 2-piece, kind of like a diamond embedded ceramic. It's the piece on the right-hand side actually gets pinned to the pump shaft, so it'll be pinned right through that little that little U-shaped notch at the top, and so that will rotate with the shaft, but it rotates inside the second piece, which is pictured to the left. And one of the really nice features of this particular bushing is that it has about a 1/1000th of an inch clearance between the two. So any fine sand or particulates, it's impossible to get it through there. And the reason I say it's impossible, and to put this into some perspective, is that a single human hair measures a greater diameter than what could pass between those two segments. So pretty cool bushing that they have there. And as we're going to move off bushings here real quick onto some impellers, but here's an example. Here's an example of where one bushing can have advantages over another. So this was, I believe, some either in-house lab testing or local field testing that we did down there at Abernathy. And this was a shaft that can show wear patterns due to particulates and or corrosivity, so that you can see in this particular application here, where that rubber bearing was placed on that shaft, it's already starting to show wear pattern. You can see it it's very visible down there. Whereas you move over to the left where the Vesconite bearing was located, there's little, if any, wear at all. And so this is kind of proof in the pudding that various bushings have advantages over others within certain applications. When it comes to the impeller options, again, we've got opened or enclosed impellers. Open impellers tend to be seen as what I guess we would call non-clogged. This open type impeller is oftentimes used. In fact, our parent companies, Zoller Company, they own a company down in Louisville called Zoller Pumps, and they use a lot of these non-clogged type impellers in their grinder and sewage pumps. Low lead bronze that's an industry standard. It's got chemical resistance, but we're also can make impellers available out of cast stainless steel, 304 stainless steel, and the applications as indicated are for high abrasives or additional chemical resistance. Wolf can custom trim impellers down there, and they do. I mean, they can build these. If it's an engineered spec that we have to meet, we can build these pumps to hit right on the specified design points, and they can do that oftentimes by trimming one or more impellers. Wolf would every day say that they could trim every 1/16 of an inch, but I think if you ask the folks down there, I don't think there is any limitation on how much trim or how little trim that they can provide down there. And some of our build centers also have lathes where they can do the same thing in-house at their facility. And then Wolf also has a 4, 5, and a 6 inch, at least at the time I put this presentation together, which is probably a couple of years ago, but open stainless steel impellers. And another little exclusive here for Wolf, in addition to that ceramic bearing you saw earlier, is these stainless steel open impellers here. I would tell you and would want you to know that every single impeller that goes through that building, bar none, 100% is going to get balanced. And that's very, very critical if you're going to, spend the time to make sure your pump shaft is straight. You want to make sure your impellers are also balanced. And so that's a 100% test that Wolf will do, or 100% process that Wolf will perform on each and every impeller that, like I said, goes through that building down there. The impeller placement. I want to talk about this a little bit, because a lot of people, these aren't things I don't think that oftentimes come up. But I was actually at Wolf a year and a half ago. I spent the better part of a week down there and making these kind of discoveries. For example, here are 2 submersible turbines pictured on the top right of your screen there. And I want to try to draw your attention to the areas that I have outlined with the white boxes. On these submersible turbines, there will, not maybe, there will be some water that's going to come out and escape under the impeller in the area called the skirt. And so that water is got to have a place to go. I'm going to blow these up just a little bit bigger so you can see this. So if you look on the left-hand side, and versus this right-hand side over here, Wolf has a passageway. Because the way that the casting is molded, Wolf has a passageway there so that any water that comes out under that skirt has a place to go. Over here on the left, it doesn't matter whose brand this is, it's just a competitive brand. But the point is, these are not, they are not the same type of pumps. They're not the same quality of pump because there's no place for that water to go. And when you start doing that, you start running water into a wall that's made out of cast iron, which is about what it's looking at right there. It will eventually make its way through. And this is how it will do it. this is the result of that type of an impeller placement. And over time, that water will jet its way through. It'll erode that cast iron away, and by golly, it'll create a path. You know, water is the universal solvent. It'll dissolve almost anything it comes in contact with if it's left in contact long enough. So it'll make its way through. That will not happen on a Wolf bull. Excuse me. I'm having to move my dashboard here just for a second to get it over on the back side, right side of the screen. Discharge castings. This is real quick. In Wolf's terminology, they've got a couple of discharge castings. One they call a red top, and again, this is more an internal description than anything else. It's not red in color. It's just an internal description. But a red top will include one of two things. It'll either include a discharge bearing and a collar like you see up there, and that bearing can be opened or closed. On this bearing here that we're talking about that supports the top of the pump shaft. And then on the pumps that we build that are 3 stages or less, we're going to go ahead and put a factory set up thrust bolt right in the top of that discharge, and those are all called red tops. And then, of course, the second type of discharge is available is a white top, and it's got no bearing and no collar, and it's simply a discharge like you see pictured in the bottom of your screen right there. So again, these are going to be available in the variety of sizes that Wolf manufactures, but again, it's just a plain discharge, nothing else added to it. These discharges are made out of a class 65 ductile iron, and we use that material because of the added strength that it provides. I'm going to talk a little bit about Wolf bulls. This is an area that I think, this is an opinion, but it's an opinion that I think Wolf has, they're at the top of the pyramid when it comes to quality of their bulls. First and foremost, when I talk to anybody about a Wolf pump, I tell them that a lot of the Wolf bulls and a lot of the popular Wolf bulls are glass-lined cast iron. They've got vitreous enamel on the inside of it. So it makes that bowl very, so that the water goes through there very smooth without much friction. We get higher efficiencies through it. You think of these submersible turbine pumps, I don't care how many stages are in there, you know, the one objective in mind is to get water through that pump as quickly and as efficiently as possible. And when you can smooth off the inside and the interior walls of that cast iron, you can reduce that friction. And much like they glass line the inside of a water heater, it also adds protection against corrosion in there. So when it comes to these glass line, they provide smooth, less friction. However, we also make bowls out of a class 65 ductile iron for the same reason our discharges are manufactured out of that material, and that is the added strength that it brings to the table. And so there was a company out there a few years ago, and I'm just going to go ahead and tell you this. They claimed they had a glass-lined ductile iron bowl, and that is not possible. You have to heat that bowl up cherry red to get that glass lining to take, and when you do that, if you have ductile iron, you just lost all your strength. So it's not, you can't have your cake and eat it too. And I think they've since retracted on that. In fact, I know they did. And so you got one or the other. You either get glass lined or you get ductile iron. Wolf is looking at other materials that would be able to come into play perhaps and provide that advantage on the ductile iron as well. But the ductile iron is going to be great for deep sets, high pressure, mining and oil field applications, and again, wash down applications, which are oftentimes high pressure. Wolf also now has a line of stainless steel bowls as well, and that I believe goes to 10-inch. That's what got us to the 10-inch on our offering. And again, stainless is going to be used in high corrosivity, typical of mining and saltwater applications. Threaded or bolt together? That's a debate that has existed in the industry for some time. Wolf, the overwhelming majority of all the submersible turbine pumps we've built and have built in the past are all threaded together. They thread the bowls thread together. On the right-hand side, you're going to see an example of a very comparable pump, and instead of it threading together, it bolts together. All right, so let's talk about advantages and disadvantages. Is there one advantage of one over another? Well, let's look at just take any size we want, but for this discussion, we'll use a 6-inch submersible turbine. And again, this was something I actually performed at Wolf that week I was down there. They had a threaded submersible turbine pump in-house. It was another manufacturer, but took it apart, measured the inside diameter. And again, I mentioned a few minutes ago, our objective is to get water through as fast and efficiently as possible. And so when we looked at the inside diameter on this threaded bowl here, the bolt together bowl, it was about 4.625 inches, where with the Wolf bowl, because we don't have to have that additional real estate to bring bolts through, we were able to maintain a fairly significant inside diameter of a little over 5 inches, which equates to about a 15% larger ID. Again, if you're going to put bolts around here, you've got to have some material for those bolts to come through, and you can't take and gain it on the outside diameter. Otherwise, you would no longer maintain your 6-inch submersible turbine. So the only place you can do is steal it from the inside. Assembly time. And again, this is important, I think, to those customers out there that are build centers. But you can assemble a Wolf threaded bowl 5 times faster than any comparable bolt together bowl. For example, down at Wolf, they were able to build an 11-stage Wolf pump, and they were able to build that thing in less than 30 minutes. It took about 2.5 hours to build the same 11-stage bolt-together pump because, I don't know, there was somewhere up around 90 or 96 bolts that you had to torque down. You had to torque every single one of those bolts down on every single bowl. And so it takes a lot of time. So I guess, if you're building these things and you need to build them quick because the customer either needs it today or tomorrow, when you can build, 5 Wolf pumps for every bolt together pump, I think that's got some advantages to it. However, this is a comment that I've heard many, many times from contractors, particularly as I've traveled the country in the past, and says, I don't like those threaded bowls. Why? Because you can never get them apart. Well, I'm going to tell you something. That's not true with a Wolf. That is absolutely not true with a Wolf pump. Now, I want to tell you why that is. If we look at the Wolf bowl design, it has what we call concealed threads and a watertight flange. So here's an image up on the screen where these two bowls are engaged, the thread engagement here. All right, so let's talk a little bit about that thread engagement there. Here's a little closer image that so you can see that there. But when these two flanges come together right here, that's watertight, irrespective of the threads. That's watertight when those two surfaces come together at that pump point. So we have the male threads at the top. The male threads are chamfered at the top to eliminate any burrs or thin starting threads. Again, that's part of that machining and quality check that we do in the manufacturing process. But you all have had the opportunity to put a nut on a bolt. And how many times have you had to kind of back that nut off counterclockwise before you could get the threads to engage, and then you could go ahead and thread the bolt onto the nut onto the bolt? Well, a lot of times that's due to very thin starting threads. So we don't have those at the top. When you build these pumps in a horizontal fashion in a chain vise, you bring the one bolt up, you spin it with your fingers, and it bolts right up and snugs right in. The female threads, they don't start at the top, and they're deeper than the male threads are. So again, when the male thread is going to sink down into the top of that bowl before it engages in those female threads. So again, no thin starting threads, and then the mating flanges, as we mentioned, are watertight. So that all said, is it just lip service, or is this really something that can come apart very quickly? Well, an opinion I'll share with you is I'll say that not only can you assemble these pumps, Wolf pumps, faster than a bolt together, you can disassemble them faster than a bolt together too. And the proof in the pudding is available on YouTube. We were down at Wolf, I don't know, it's been a year or two, maybe more ago, and they took a 25-year-old Wolf pump out of the graveyard, and the graveyard out behind the factory. It's set out in the weather forever. But this pump was 25 years old. The guy brought it in. He shoved it in a chain vise like that. And then I'll make a concession to you. He took a hammer, a mallet, and he banged around that top casting in about 3 different areas. Once he banged around that top casting, he put a strap wrench on there, and just with a tug, he popped that first discharge or that first bolt casting right off of there, and he was able to do that in the subsequent ones as well. Key is no heat required. And I know for a fact that there are competitors of ours that will tell you right in their manuals that if you're going to take their pumps apart, especially if they're a threaded bowl design, you're probably going to have to use heat. But we're able to take those bowls apart without that. And again, it's all because of that. Sorry, excuse me. It's all about that thread design. I need to get a little slug of water here. Sorry. That I talked to you in the previous slides. The bowl design when it comes to bowl thickness, and I'm about done with the bowl design here, and we'll be winding this off probably in the next 10, 15 minutes. Without saying too much, I went to a trade show one day, and I had to do a training class at the trade show for CEU points, and our rep happened to have a tabletop display at this open house, distributor open house, and I noticed after I got done with my class and walked into the exhibition hall that he had 2 bowls sitting on the table, and only one was a Wolf. The other one was a competitor. And I walked in there and I said to him, I said, dude, I said, I don't think this is something that I would be doing if I were you. What's that? And I said, well, I wouldn't put a competitor's bowl out here on the table. Oh my God, they're in this same room. How would you like it if they had one of your products down there on their table dissing it? He looked at me and said, Mr. Painter, I didn't put that there. I said, what do you mean you didn't put it there? He goes, no, the branch manager put it there because he said when the contractors come by, have them pick these bowls up. They can tell just by holding them which one feels more robust than the other. Well, that was certainly a fact, and you know, here's the reason behind that as well. You look at the robustness of the casting versus a competitor casting, and you start to get that jetting of that water that erodes those castings. You get thin walls on here, you shoot the water right out the side of one of those bowls. But anyway, here's another reason I think Wolf should be under consideration, because their bowls are very robust, up to 20% greater wall thickness. And so when it comes to bowls, you got glass lined, you got ductile, up to 15% larger ID inside diameter. It goes together fast, it comes apart fast. And the wall thicknesses, like I mentioned, up to 20% heavier wall thickness. So we're going to wind this little web conference down with just some of the testing that's done at Wolf, in addition to the quality checks that are made, you know, before, during, and after manufacturing. We do 100% factory testing down there at Wolf as well. Inside their facility is like I said, this is a world-class testing facility. Every pump up to 500 horsepower is going to be wet tested before it leaves the factory, because not every pump that leaves the factory leaves with a motor. There's a lot of areas that they'll check that pump for. Like I said, that they can meet design points if they're engineered specs. No problem there at all. But within this test facility, as you see laid out here, coming up on your screen here, it looks like it's coming a little slow, at least on mine. There's a 70,000 gallon test pit. And in addition to that 70 gallon test pit, there are 2 60-inch casings. They're 85 feet deep. So we're able to test a variety of different size pumps, you know, up to several thousand gallons per minute, 10-inch all the way down to the 2-inch pumps. And then when we look at the tower, this is the tower I mentioned to you as we started this conference today. That's a 66-foot tower with a 4-ton crane. So they're able to lift these pumps up. We don't have that luxury in Kendallville, Indiana. We do build a handful of submersible turbine pumps up there, but we're limited on height. And so with this tower down there, many of the Wolf pumps are manufactured right there at that facility, and much of the time because of their ability to test. They can do significant strategic testing for vibration analysis and harmonics. They can do phase imbalances at different RPMs, particularly if that pump perhaps is going to be operated off of a variable frequency drive. So much of what can take place in this test facility is pretty significant. They've actually got a 360-degree digital camera. So that remote witness testing can be done anywhere in the world. So if any customer wants to actually see their pump being tested, they can log on and they can actually view it and see real-time results. If you happen to take a Wolf tour, there is an observation deck down there as well. Pretty cool. But what you can do is, as a customer, you can go up into that observation deck and you can sit above that test facility and see real-time results again as these pumps are tested prior to being packaged and shipped. Speaking of shipping, and I'm winding down here, this is a category of product that historically you need to be able to ship, and you need to be able to ship either today or tomorrow, or certainly within 2 days. Outside of that, you're probably not going to get the order. Because these pumps, when needed, they need them now. And so I believe that Wolf is again, unprecedented in their ability to ship. As you can see on this map here, and again, we do ship some product from Kendallville, Indiana, which is kind of up in this area here where my cursor's at. But the bulk of them, because of the size and our limited ability to test submersible turbines at our factory in Kendallville, the bulk of them are going to be shipping out of Abernathy, Texas. And as you can see, most of them are within that 1 to 2 day window. All right, folks. Well, we're winding down here. Again, appreciate your time today. I've got a couple more another web conference tomorrow on irrigation pumps, and then a couple next week. And like I mentioned, please check back on this the Flint Walling website, because I am in the process, and by the end of this week, we'll have a June schedule posted. And I'm going to bring some new topics in for that month of June. And then the other thing is that when you're on that site where you register for these web conferences, also just be aware, just above that schedule, and I've recorded this one as well, we are putting web recordings out there in an archive, so that if you have somebody that you want to have sit in and wasn't able to make it, they can go to that website and click on one of those topics there and get a web recording. The last thing I'll mention to you, and this is my last slide, I tried to get this to download onto this web conference platform, GoToMeeting or GoToWebinar, but I was not able to do that today for some reason. I've done it in the past, but here is something you might be interested in. I got the form number up there, and I'm going to leave this slide up for a while. But if you would like a copy of this presentation that I've just conducted in the form of a PDF, this is a Y-Wolf booklet, and it's got most of the images and the commentary in there. And I apologize for whatever reason I couldn't get it to load on this platform. But you can go to our website, or if you want, just drop us a line here. You've got ability to chat, and you've got the ability to email us at marketing@flintandwalling.com. Let us know that you would like a copy of this, and we can email you back the PDF copy. And I'm going to leave this up here again because it's got that form number that you're looking for. Anyway, folks, I appreciate you. Appreciate the time we had today. But with that, I'm going to go ahead and close this web conference out and ask that you all continue to be safe. Thank you very much. This web conference has now ended.